So we're going to go in a little more detail into how the AI works for semantic cue detection in the events that transpire on the back end when you hit apply style here. So you're making a language instructor video, which means you're going to be talking about words in a different language. So like there's basic greetings in Swedish. You say hey in Swedish. You repeat after me, hey. And the system is going to have this abstract vocabulary of semantic cues, noticing when you've said, say, hey, and then according to these guidelines that you specify, first, this is a language instructor video. You just want to be playful and fun. You want this color palette, you want whatever typography, and you have some kind of logo in here. Okay, and you've hit apply style. And so what we're going to be discussing here a little bit is this sophisticated semantic cue and an animation snippet system that we've co-created with the artificial intelligence. So there are two types. There's a system A and system B, which is, well, how are you going to empower a designer to create animations that are triggered to different semantic cues? And then how are you going to detect semantic cues in text and apply the relevant animations? These are the two subproblems that we're focused on. And now we're diving into the piece about the LLM here. So let's see. Yeah. The semantic cue system is a tree-based data structure such that there are abstract events that apply in nearly all cases, and then highly specific events that are more narrow to the exact thing that's happening. And if you can't find a very specific event, you just work your way up in the tree and find the more abstract event. So that's how the data structure works. And yeah, so we can think about some examples of this, like you say a new vocab word. There's the first utterance of some word, and the letters just fall, land suddenly, basically. That's what happens when you say a new word. Or there's a repeat. You're repeating. You say, repeat after me. Hallå, hey, hey. Say it with me, hey. And then a sound wave ripple or whatever. So these are events that are detected. How are they detected? This is what we're trying to figure out, but we're using a vector embedding for this. So we have a vector embedding that's linking the events to animations, and then an AI that is suggesting encodings for this. So yeah, now we're iterating on this actual prompt to the LLM in here. So we don't necessarily just want to pass it the segment text. We also want to pass it the surrounding context. So this is how we're structuring the data structure. I've said that these are maybe irrelevant, but perhaps not. I don't know. Maybe there's other stuff. I think these are irrelevant. Okay, candidate cues. These are, it's saying that there's maybe a vector search that has already been active, and you're putting these in here. So I have to think about that, whether there's a local intelligence that we can apply with our vector database and place candidates in the prompt to the artificial intelligence. So global instruction, max queues to return per segment 3. Yeah, it's nice. Min confidence for max, for match. Yeah, having a confidence in structure. So now this is like a specialized piece of intelligence where we're prototyping it just with OpenAI, but we can fine tune OpenAI and we can build our own dedicated LLMs for this. In fact, that's what this Vibetube is going to plan to do. Okay. The LLM detects semantic cues for chapter, iterates through segments, right? So that's how it works, but we're here. So this is how the input is, roughly like this. This seems quite right. And then the output of the schema. So this is the data that we'll be expecting. The data, we want it returned an array of all semantic cues that confidently match the segment text, right? Oh, Q type, object Q type, start time in segment offset. Oh, I see. Yeah. Oh, yeah. But how's it gonna know the offset? Yeah, it's just estimating it. Yeah. Right, when exactly to apply the segment in the offset for the animation. Christ. Okay. Well, it could just start time and segment offset. Yeah. Time array also. Yeah. Start time. Offset. Right. Okay. So the end time LLM confidence source. So for each, so this is an array of detected cues. Beautiful. Yeah. Required Q type. Oh. LLM extracted of key value pairs corresponded to the expected data parameters of the matched Q type. Okay, but extracted data description. How's it gonna get? Oh my god. This is stupid. Okay, how's it gonna get the parameters to the segment if the point is to choose the segment, the semantic cue? I know the parameters in advance. There's a bug with it, chat and text. Okay. construct the prompt for the LLM Q evaluator, the system prompt and user prompt for the LLM call inside semantic Q detector would look something like this. You are an expert linguistic analyst specializing in identifying semantic cues in spoken language for automated animation generation. Blah, blah, blah. Whoa, 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 whoa. For each... Your task is to evaluate a given text segment against a short list of candidate semantic cues. Against a short list. I'm not sure. Versus the yeah. Local intelligence, right? For each candidate Q, consider its description example triggers. If you determine that the current text segment confidently matches the semantic meaning of a command candidate Q, current text segment, identify the exact triggering phase text within the segment. Determine the start time and segment offset. Yeah. Maybe this is an approach. Okay. User prompt. And this is what we call it. Sandbox. Okay. Yeah, so we can see what it says about this. I'm not, we're iterating on the prompts here. So let's see what it thinks about my feedback here, because I'm not convinced about the candidate Q approach, basically. So let's see what it says. We need to consider the shortlist approach of sending it semantic cues. This depends on the quality of the local intelligence and the vector database matchup. I think I'm gonna go for a different solution to it. Planning. I'm currently evaluating the semantic cue detection. I'm focusing on extracting animation parameters. The shortlist proceeds. Yeah. How the system... No, it's not... Yeah. Okay. Well, we're going to think through this.